as we continue our quadratics unit, we are now going to talk today about a couple of things called the focus and the directrix, and they actually are very much interrelated to each other. So again, we've talked about parabolas, but we haven't talked about before where a parabola's shape comes from. We've talked about how it's symmetrical, and that there's an axis of symmetry that if I folded over it, I'd get two sides that are the same. But why does it act that way? And here's the reason. Okay. So we've got all these sets of a point. They're the same distance from a single point called the focus. Now this is a little trickier to see. This picture does a pretty decent job of it though. This dot called the focus, and it's not always going to be on the x-axis like they have it in our example here. But no matter where I go, there's always going to be an equal distance between, like, let's say if I had a line going this way to the exact same point that's symmetrical, they'd be equidistant. They'd have the same distance to the parabola. And that's going to be the same no matter how far away I am from the parabola. If I was going way up here, they'd be the same. But you also have that same distance between your focus. So it's the same distance from my focus to that point on the parabola as it is from that point on the parabola to a horizontal line beneath my parabola, which is called the directrix. And what you'd end up having is this proportion that you can use to be able to figure out the focus if you have the directrix in the parabola, or vice versa. Or even if we have the focus and the directrix, we can figure out the equation of the parabola. So there's lots of little pieces where these things kind of intertwine. This gets a little more complicated looking at D1 and D2, but the main focus here is that they're the same. Okay? So when we boost up just a little bit here, identify the vertex, the focus, and the directrix of each, and then sketch the graph. Now I am going to make one reference point back here to the formula sheet that you just got. On the back of it, okay, this is the format that works easiest a lot of the times, but I want to make one mention because you're like, okay, that's vertex form. But I look at these first two, they don't look like they're in vertex form. They look more like maybe standard form. So, what do I do with that? Well, on the other side, you're like, it's kind of closer to this. And I agree with you. But there's an easier way to look at this to me. When you're doing these, I know it speaks here of this p-value that we have, but for our purposes and the information we're given, you also can look at your focus as being 0, 1 over 4a, and my directrix as being y equals negative 1 over 4a. And you're like, well then, why am I given this? For the most part, what we're going to be doing, we're going to be able to find that a value. Because if you remember, this 4p would be the same thing as having this x squared equals ay. So instead of having to do the extra step of dividing by 4 to figure it out, I should stay here for a minute in case some of you are still writing. When we get to the other ones, I can just take that value in front of my y term and get to where I need. In other words, when I come here, I look and I say, okay, my a value, my value in front of x squared for my standard form is 1. So when I'm doing this, I'm going, okay, well I know for y equals x squared that my vertex is going to be at 0, 0. It's my base graph. I just know this. So before I go trying to graph the rest of it, where is this focus and where is this directrix going to be? I personally am going to do this in the opposite order. I'm going to sketch the graph, at least in the first couple, so you can see how this works. So if you remember before when we went a charting with these, that we'd get that 0, 0, or you can do it on the graphing calculator. But again, x squared is an easy enough number to work with that I probably can just come up with some values pretty quickly on my own. Since I'm just squaring it, 2 squared's quick, 1 squared is quick. And so I'll get my dots plotted. Okay, so visually this is going to be a little bit easier to see when we go to do our focus and directrix. Because again, it needs to be equidistant from each point on my graph. So I look, and when we just mentioned that my focus can basically be found by doing 0, 1 over 4a. Well, if I know that a is 1, because that's my coefficient in front of x squared, my focus would be 0, 1/4. So this may be a little trickier to graph because there's not a whole lot of room here, but so there's this little dot right above my vertex. And my vertex and my focus will always align vertically. So then you're like, okay, so the focus is 0, 1/4. What's going to happen with my directrix then? So I look to what we just wrote, and I'm like, okay, so my directrix is going to be y equals 1 over 4a. Negative 1 over 4, excuse me. And since my a is 1, my directrix ends up being y equals negative 1/4. And again, that can be a little tricky when we're visualizing here, but we'll make it work the best we can. And you're going to start, once we do a couple of these, to see a pattern. You're like, well, wait a minute. The focus was at positive 1/4 for y. The directrix was at negative 1/4. And whenever it's at 0, 0, or it's on your x-axis, that's going to happen. These will basically be inverses of each other. One will be positive, the other will be negative. If I know one, I'm going to know the other. And that's all I'm looking to do. Now again, I could do all of this without having the graph there. I can. But I just want you to see on these first couple how visually this is going to work. On the next one, the only difference is my a value is going to be 2. My vertex isn't moving. The only thing that's happening is my parabola is getting a little bit skinnier. Because if I think about the values, I'm like, okay, if I plug in 1, 1 squared is 1, times 2 would be 2, and I know it's going to be symmetrical, so I can use that for 1 and negative 1. If I plug in 2, 2 squared is 4, times 2 would be 8. Put me to the very top here for 2 and negative 2. So I get my nice curvy parabola. And then I just use that information that we just found to help me out a bit. So basically, all I'm going to do here for my focus is I'm going to use 0 and then 1 over 4a. So 1 over 4 times 2. So my focus would be at 0, 1/8. Which is even trickier to see. You gotta pick these blasted small little tiny numbers. But you do start to notice your focus and your vertex are going to be very close together on a lot of these until we start getting some movement in them. And then with that, my directrix is negative 1 over 4a. So negative 4 times 2 would be negative 1/8, but that's a y equals because again, that's going to be a horizontal line just below the vertex of my parabola. But again, it's all about them being equidistant from each point on my actual parabola. Any issues so far? We're trying to keep life as simple as we can here at the start, and then we can kind of build once we get it not centered at the origin. So anything at the origin, it's as straightforward as that. 1 over 4a with my focus and negative 1 over 4a with my directrix. They're like, can we get to the fun ones yet? Almost. One more of the easier ones, and then we'll kind of kick it up here a little bit. Still no movement, just an a value that's different. So again, we're still going to be at 0, 0. But now we've got an a value of 1/3. Our graph is going to widen. So you're like, okay, now, this is one where some of you may look a little more for some assistance. Because you're like, okay, 1 I can handle. I mean, 1 squared is 1, 1/3 of 1 is 1. 1/3 of 1 is 1. 1/3 of 1 is 1/3. So I'll get those in. But then it may be more in our best interest to use a value for x that'll be a little nicer, like 3 maybe. Because if I use x equals 3, 3 squared is 9. 1/3 of 9 is 3. A little bit easier than the decimals, or if you want to use the calculator, using the decimal isn't a big deal. And I get a much wider parabola. We might actually be able to see our focus this time. So again, when we're doing the focus here, it's 0. Ooh, careful here. 1/4 times a. Ooh. You're like, okay, well, 4 times 1/3 is 4/3. So here's what I want you to remember. Because again, I don't have to go to the calculator on this. If I have 4 divided by, oh, not divided by, times 1/3, okay, that's 4/3. But remember, 1 divided by 4/3. When you're dividing, that's the same as multiplying by the reciprocal. So really here, what I'm looking at for my focus is 0 3/4. It won't be a fraction. I don't want like 1/4. That's not telling me anything. If I came up and asked you to tell me, well, what's 1/4? Okay, well, until you can give me a direct answer. And again, you can go to the calculator if you need to. But that's how I deal with that fractional issue. If I'm dividing by a fraction, you're basically taking its reciprocal. I can actually see my focus this time, 0 3/4. Anybody care to venture what the directrix is going to be? There you go. My directrix is going to be y equals -3/4, because again, it's going to be equidistant from not only my vertex, but from all the other points on my parabola. You're going to get to a point you're going to wish they were all doing it this way. But again, you've got your form, which would just be -1/4 times 1/3. That's where this is actually coming from. Because just remember, it's going to be that same form. I'm just going to write it so you've got a reference as to where this is coming from. It's just -1/that. But again, nothing real complex yet. Like, oh, yet. Why is there going to be a yet? Why can't it just stay normal? All right, our vertex is about to move, which is going to make our other information move. So let's see what we got here. What's our vertex going to be on number 5? -1, -1. Because again, it's x minus h plus k. Change the sign, keep the sign. So -1, -1. Okay, we've got ourselves a dot. Now, let's see here. Now we're not centered at the origin anymore. Oh dear. So now if, at least for the time being, we want to come back to our reference sheet, I would be working with the ones over on the back now, because that looks similar to what we're working with here. So we just found our vertex, our HK. Now we're going to go looking for our focus. So now our focus is going to be H, whatever this value was originally, which is going to be -1. And then we've got K plus 1/4a. So in some ways, it's the same as what we've been doing. We're just adding that to our vertex value. So let me move this up a little bit more. Maybe we can get everything in the screen at once here. Oh, check that out. Okay. So when I'm going to find my focus, let me change colors here, because we can find our focus in Directrix first, or you can keep getting the graphs in kind of as a backup plan. Now again, I don't care when it comes to graphing these if you plug in numbers. Some of you are comfortable working along, making a chart, and going from there, even though I still think it's more efficient for you to just use the calculator rather than trying to sit here and figure out, okay, well, sometimes 0 plus 1 is 1. 1 squared is 1, minus 1 would be 0, which would give me both of those. 1 plus 1 is 2. 2 squared is 4. 4 minus 1 is 3. I can get my points just as quickly kind of using my brain as I can taking the time to plug it into the calculator. But if you're more comfortable with the calculator to get those points, that's okay. But back to our main focus on this side, finding the focus in the directrix. So here my focus, my h value is -1. And then for my y value, it's k plus 1 over 4. And since I don't have a coefficient that I see there, it's just going to be 1. So my focus ends up being at -1, and that's going to be 1/4. What's -1 plus 1/4? -3/4. Real tight here with my vertex again. So I start to sit here. Now now that we're starting to move the vertex around, it doesn't make our directrix quite as simple. I can't just take the reciprocal and say, oh, it's going to be at 3/4. No, it's not. Because my directrix is always going to sit underneath my vertex or above it if it opens down. So here now with my directrix, let me scooch this back up a little so we can see that. We've got y equals k minus 1 over 4a. So we're still going to end up seeing a pattern develop here. So -1 minus 1/4 is -1 1/4. Here's what I want you to start thinking about, because patterns help us to make these easier. If you think about your vertex's y value, it's -1. Okay? My focus was at -3/4, which is 1/4 away, 1/4 above -1. My directrix is 1/4 below that -1. So there's always going to be a direct relationship between your y value's distance from your vertex's y and then equidistant above and below that with my focus and directrix. That's never going to change. But again, knowing the formula is going to be your key on that to making that simpler. So for any of these we do, this one may not look like it's the same form, but again, it's going to be because we're shifting. Our vertex isn't going to be at 0, 0. Speaking of, where is my vertex going to be on number 6? Yeah, my vertex is going to be at 0, -1. And what direction is it going to be opening? Down, because my A is -1. So I'm like, okay, well, let's see. Let me do a quick sketch over here so I can get my values situated. Again, just a couple of values above and a couple below, whether by calculator or your brain. I like using my brain. Be careful though, that negative is after you square your value. So for instance, if I'm using the 2, 2 squared is 4, then put the negative on. So 2 squared is 4, which would be -4 minus 1 is -5. And that'll get me set on each of those. And then 1 and -1, again, 1 squared make this -1 minus 1, or -2. Because you always need to be symmetrical on these. If you're not, if your values come out different, something didn't quite go right. So opening down is going to change a couple of things. My focus will still be inside of my parabola, but my directrix now, instead of being below it, is going to be above it. But the formula is not going to change. So again, when I'm finding my focus, it's going to be my h value, which in this case is 0, And then my k plus 1 over 4a. And again, just until you get used to it, I just kind of keep writing it out this way, and then you'll start knowing the formula off the top of your head, and it'll be simple. So negative 1 plus negative 1/4. So we'd be at 0, negative 1 and 1/4. And that's a good sign, because if I'd have done my math work and it would have ended up outside the parabola, I know I did something wrong mathematically. So once I have that, I'm like, okay, now there's a couple of ways I could look at this. One of them would be to say, okay, y value of my vertex is at negative 1. Focus is at negative 1 and 1/4, which is 1/4 away. So I could go 1/4 back above. So negative 1 plus 1/4 is negative 3/4. I just know it off the top of my head, and I go about my business. But if I don't think of it that way, if I don't remember that, I can always do k minus 1 over 4a. And again, I look at that and I'm like, oh, minus negative 1/4 would make that plus 1/4, and that's where the 3/4 is coming from. So again, don't let things be a pain in the rump when it comes to this. Just work it out, use your a value, and go about it. All right, one more, because I want to make sure, again, now we're going to kind of blend everything together here. We're going to shift, we're going to change the a value, see what we got here. Where's our vertex? Negative 2, 4. Now, a little more mental math to do this time. And we still got 0, though. We like 0. So let's see. 0 plus 2 would be 2. 2 squared would be 4. Negative 1/2 times 4 is negative 2. Plus 4 is 2, so that sets me up for both of those. Negative 1 plus 2 would be 1. 1 squared is 1. Negative 1/2 times 1 is negative 1/2. Plus 4 is 3.5, or 3.5. And again, if you want to type this in the calculator and just use the table function, you can. If you want to plug in your x values in here and type that into the calculator because you're not real confident with that, that's okay. But otherwise, I can get those guys working. And again, it's just getting used to the formulas with things. My focus is always going to be my h, and then my k plus 1 over 4a. So let's see, what's that going to be? 4 times negative 1/2 is negative 2, so this becomes negative 1/2. So 4 minus 1/2 is 3.5. So negative 2, 1, 2, 3.5. It's inside my parabola, which is the key. Then again, when it comes to my directrix, I like to find the patterns, so I'm like, okay, my vertex, the y value was 4. For the focus, it was 3.5, which means there's a 1/2 difference. So now instead of the minus a 1/2, I'm going to add it. 4.5. And we're good. Just keep reminding yourself, as long as your focus is inside your parabola and it's equidistant, your focus to the vertex and also your directrix to the vertex, that will help you because you probably won't even have to remember the formula for this as much. It's still good to know, though, just in case you're asked for some other information. Like, Use the information provided to write the vertex form of the equation of the parabola. Okay. So we remember our vertex form of the parabola. So you're like, okay, I need an a value, I need an h value, and I need a k value. As long as I have those three things, I'm ready to go. So, cool thing right off the bat. Vertex is at the origin. Okay. So I know h is 0 and I know k is 0. So I've already got those two checked off. The only thing I need is the a value. Okay, let's see. How am I going to find my a value? Let's look at this formula sheet for a minute. There has got to be, just got to be a simple way to do this. Oh yeah. Remember, since my vertex is at the origin, my focus is just 0, 1 over 4a. So if this is 0, 1 over 4a, I can figure out what a is by setting up a simple proportion. Because then all you do is cross multiply and set them equal. So I've got negative 4a equals 4 by cross multiplying. So my a value is negative 1. Okay. So now that I've got a and h and k, I'm ready to plug in. So y would be a x minus h squared plus k. Now, can I leave it that way? Sure. Do we normally leave it that way? Not really. Because when I can simplify, x minus 0 is just x squared, and the plus 0 I don't even need. Both perfectly acceptable. I wouldn't mark it wrong if you left it this way. But that's just a way to kind of simplify things a little bit. But that's all I'm up to with these. I'm kind of turning them into algebra problems to figure out, okay, where's this focus and directrix? What am I going to use? And the information's going to change. Okay, my vertex is at the origin again for number 9. But now I'm given the directrix instead. Okay, so let's see. What do I remember about the directrix? Oh yeah, when the vertex is at the origin, it's negative 1 over 4a. Okay. So if y is negative 1 over 4a, I've already got the negative 1 part. So again, if I wanted to, I could set up a proportion, but I really don't think I'm absolutely going to need it each time. Because those basically take care of each other. So negative 4a is negative 12. A is 3. I could have just set 4a equal to 12 because the denominators would be the same then. And again, I'm ready to roll. So you're like, so really the only difference here is going to be those zeros are still going to kind of disappear, but the a value is different. So it's just y equals 3x squared. I'm good. And you're like, yes, yes I am good, thank you. So, now again, we can keep shifting things though. Oh great, he's going to start moving stuff. Oh, the vertex is moving this time. That's not a big deal. Still have my h and my k, that's fine. But now my equation, I'm going to have a little more thinking to do. Because again, my focus isn't going to be that 0 value anymore. Okay, my focus is going to change to what we were using up above. The h and the k plus 1 over 4a. So let's see how that compares to what we've got here. So we've got h, we've got k plus 1 over 4a. So let's see what we've got working here. Well, the h's are the same, so that's not a big deal. These are the two things I'm going to be setting equal. So I'm like, okay, so I've got negative 4 plus 1 over 4a equals negative 15/4. Again, we're just playing the algebra game here. So I look at this and I go, okay, let's see here. if I add that 4 over, and again, I've got to play the common denominator game here. So just a reminder to myself, negative 4 as fourths would be negative 16 over 4, because I multiply by 4 to get my new numerator. I have to do the same here. So here's what I'm really looking at. And now life should become much easier, because when I add the 16 fourths over, now it's just 1/4. And I'm like, all right, this isn't going too shabbily here. So 4a equals 4. Make sure everything's going okay here. Did I do something silly? I don't think so. Nope, 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 nope. We're going good. Okay. So if 4a equals 4, a is going to equal 1. But this time my equation's going to be a little bit bigger. It's still going to be, ooh, I'm all tilted here. It's still going to be in the same order. So my a is 1, I can put it there, but I don't have to. X minus h squared plus k. So that's what I'm kind of looking at here. I've got to keep an eye on some of the changes that come when it moves a little bit, but it's nothing that's going to be too terrible. So one more time here. We've got our h and our k. When I'm doing Directrix here, y is going to equal k minus 1 over 4a. So I'm like, okay. So what does that mean when I make my little equation to solve here? Well, my k value is negative 1. So negative 1 minus 1 over 4a is going to equal negative 7/8. And again, if I have to play the common denominator game, I can do this. Negative 1 is just negative 8 over 8. And you will, as you'll get more comfortable as you're going along, where there's certain things, I mean, the side works, a lot of you probably don't even need to do, but I just want to make sure when we do it this first time, we're all on the same page. So I'll add that over. So negative 7/8 plus 8/8, since we're doing it like an equation, it'll be a positive 1/8. And if I play the cross multiply game, I'm going to come back over here where at least I've got a little more room. So I'd have negative 8 equals 4a. So it looks like my a is going to be negative 2. And then I just plug in all the missing pieces. So we've got a x minus h squared plus k. Lots of algebra, just basically a couple of little formula things you need to know. And again, that's what the note sheet's there to try and help out with. If it's in vertex form, using the back's good. If it's in vertex form with the vertex at the origin, using the front's a better idea. So the assignment that goes with, and like I said, we're going to be playing with this tomorrow a little bit too. Maybe playing a little bit with radicals tomorrow, but this is going to be our main focus. So practice with the focus and the Directrix, just the same stuff again, graph them, figure out the focus and Directrix, and there's some equations to build on the back. Use the examples, use the note sheet, kind of get a work on that, and then we'll clean up any loose ends that we need to tomorrow.